Okay, well, welcome everybody. I see it's 1 o'clock on my screen, so we'll take that and get this thing rolling here. Want to welcome everybody to our monthly UE Systems webinar. It's hard to believe it's already the middle of August, but here we are. Today we're joined by Tim Dunton with Reliability Solutions, and he's going to be talking to us about implementing reliable manufacturing. The past two webinars we've had this summer were from DuPont and Novozymes, really focused on some pretty impressive ultrasound programs that those two customers of ours have been putting together and having some great success. So while we love highlighting, obviously, topics related to ultrasound, it's also important to us that we focus on reliability as well, because obviously utilizing ultrasound within the framework of a pretty aggressive reliability program is going to make our technology and tools that much more powerful. So we're happy to have Tim here today to talk with us a little bit more about reliability and the things that everybody should be working towards and trying to improve upon. For those of you that might not be familiar with UE systems, this thing you're seeing on our screen here, our interactive information kit, is something that I'd be happy to send to any of you that want some more information. It's got everything from our different products to our software. We've got all of our webinars, like the one we're doing today, up on our website that we're linking to. So just pretty much everything and anything you'd need to know about us, we can get you in this email. So shoot me a note in the questions box, and I'll be sure to zip this off to you when we get offline here. And before I welcome Tim, just some housekeeping for you. We are recording this, so we will put this up on our website in just a couple of days, and I will alert all of you when it is up and online. So if you have to duck out a bit early, or you've got a colleague that just couldn't make it, that'll be a good opportunity to be able to view this after the fact. And also, as I just mentioned, there is that questions box, and so you're more than welcome to type in any questions that you've got along the way. Tim is happy to clarify anything or answer any questions while we're going through it if something needs clarifying with what he's just said, or of course we'll obviously have the typical question and answer session at the end. So without further ado, I'm going to welcome Tim here. I'm just going to change the screen over to him, so give us 1 second. And there we go. Tim, thanks very much for being here with us.
Thanks, Maureen, and hello, everybody. Glad you could all kind of make it. Today, what I want to talk about is a subject that's probably near and dear to most of your hearts, and that is, of course, implementing reliable manufacturing. You know, we are an independent organization. We deal a lot with training, but our mission in life is to try to help people implement reliable manufacturing from sort of soup to nuts. And one of the things that we see a lot is people really trying to take a piecemeal approach to this and drive technologies on little islands. And what I want to try to talk about is a somewhat more integrated approach. If you really want to get good at reliable manufacturing, then everybody in your organization has a responsibility to do this and has a role to play as well. Perhaps a good place to start would be to ask, the question, what is reliable manufacturing? What is it? Well, at the manufacturing level, it's the absolute confidence that the process starts when I want it to start, produces the quality product I want it to produce for about as long as I want it to do so. This game is all about producing product and making components and widgets. And so if we're going to define what reliability is, it has to be defined in those terms. At the asset level, though, there's another definition. It's kind of similar, of course, because at the asset level, the individual machine level, it's the absolute confidence that the asset, the machine, is going to start when I want it to start, perform as long as I want it to perform, and for as long as I want it to do so. Sounds kind of simplistic, but you'd be amazed at how difficult that is for people to achieve. Bottom line is, of course, it is the bottom line, and what we're all about here, again, reliable manufacturing is about taking raw materials and converting them into other materials which hopefully will make our companies profit. So whatever we do in the name of reliable manufacturing, it has to be very, very cost effective. It has to be, make sense. It's got to be sensible, defensible. It's got to be worth doing as well. There's an awful lot of technology out there that we can apply, but does that technology always make sense? A lot of companies we see take a piecemeal approach to getting or trying to achieve reliable manufacturing, and it's often the sort of next big thing or the program of the month, and they'll go out and they'll have a process or an initiative around a particular area or a particular subject, and from that they'll get improvement. They will see some improvement, but they tend to be programmatic rather than process orientated. In other words, once the program's finished, it's finished, and we end up slipping backwards. So many of these initiatives are not cohesive, and they're not really coordinated or strategic in their nature, which leads to quite a problem. So what does it take to do reliable manufacturing? Here's a list. I'm sure many of you watching right now can relate to many of these things. You go to a lot of places and they do precision alignment. That's a wonderful thing. It's very important. All of this stuff on this page is the right work to do. The problem is if you do them individually without this sort of coordinated, cohesive approach, then you end up wasting a lot of manpower and resources and not really seeing the results that you would expect to see. In recent years, there's been a big push to do operator equipment care, and that's a very important piece of the puzzle. But it's not the only piece. There are other things, and they should all work with a synergy. They should all work together. For example, there's a relationship between what the operators are doing in their world, plus the vibration, plus ultrasound. All of these should be tied together. And then, of course, on the other side of the list there, we have the sort of high-level stuff, things like loop tuning and safety systems and preservation, environmental, statistical sort of process control, things like that. And again, these are all the right things to do. But how do we decide which to do, when to do it, and how to do it? And that's really what reliable manufacturing is all about. What happens when you take these things piecemeal, one at a time, you create this illusion of improvement. What will happen is something will come in, you'll do ultrasound, or you'll do infrared, for example. You get a hold of an infrared camera, you run around and start taking a bunch of IR shots and seeing some things and catching some problems and making an improvement. And then after that, you sort of levels out, it plateaus out, and then along comes the next big thing. And maybe it's writing procedures, or maybe it's training, or things like that. And so you get a little bounce out of that. But then again, as you slide backwards after it, and then you do the next thing. And as a training company, we've witnessed this with some of our clients, where we'll go in and do some precision maintenance training, and the guys will come up, they'll all be fired up, and for about a 6-month period after the class, they really see improvement. But there was never nothing put in place to sustain that improvement, and so invariably it slips backwards. But all we ever see as the end user of that, as the plant people, is we keep seeing improvement, but it's not a true improvement. It's just an illusion. True improvement, to achieve that, we have to have a system to standardize the knowledge. We have to have processes, standardized processes. So after the training has taken place, or whatever the event is, whether it's technology or whatever, we have a standard way of applying it, and this is the value that it will bring to the table. We need systematic ways to develop our people, to develop the teams, and it's only then that you'll start to see continuous improvement. And again, that should be a stretch goal for everybody, to continually improve the way we do business, look for new ways to improve the way we manage reliability. So how do you build that reliable plant? If you were starting to build it from the ground up, what would that actually look like? Well, as we build the plant, it really starts for us. It's a little bit like building a house. It really starts for us with a blueprint. And for us, the blueprint is a process called asset strategy development. And I'll come and talk about each of these events and each of these things in a minute. But ASD is really the format that we use to develop the right strategies for the particular assets and systems involved. But of course, a foundational element is work systems. I can go out and do all the RCM or ASD or whatever other three-letter acronym you want to use to develop strategies, but if I don't have a way to execute the work, if I don't have a good work system in place, planning and scheduling, etc., if I don't have that in place, then everything we do, whether it's technology-based or whatever, is never going to be very effective because we don't have a way to properly execute the work. So the foundational element of all of this is a good, what we call essential work systems or planning and scheduling. Of course, if you want to improve something, you have to be able to measure it. And so for that, we need metrics and management tools in place. We can't tell if we're getting better if we can't measure it. And again, I'll talk to this a little bit later in the presentation because one of the things we seem to be inundated with today from a management perspective is metrics. Lots of plants I go to, they're measuring everything under the sun, but it's never been sort of systematically laid out. So what I want to talk a little bit later on in the session about is how to properly sort of lay out those metrics so they support their business goals. For us, the first layer, the first course of the walls is our essential skills. These are the essential craft skills, the operator skills, vibration, lubrication, preventive maintenance routines, things like that. These are foundational to everything else that we do. And if we don't have these in place, then you end up sort of bouncing on this inverted ice cream cone or inverted pyramid, and it'll all come tumbling down. It's all very well for me to go out with a high-end sophisticated analysis tool and find out there's a bolt loose somewhere, but unless somebody comes along and tightens it properly with a torque wrench, and it's never going to go away. The problems will still be there. We'll just be looking at them 3 or 4 or 5 years from now. The second level, we start to look at a little bit more technology involvement. Again, the important thing is to get the essentials in place before we try to do technology. Let the technology be driven by the essential behaviors that you have. A lot of people do that upside down. They'll grab at the technology first without having the fundamental skills or the essential skills in place, and that often leads to problems down the road. Again, systems and management systems, these should be positioned to support the existing work, not create the work. And I go to a lot of facilities today where the hoops that people have to jump through because of management systems really doesn't make a lot of sense sometimes. They get so wrapped up in conforming to the CMS system, the maintenance management system, that they sometimes lose ground. And then on the high level, we've got things like root cause analysis and life cycle engineering, quality processes, statistical process control, and all that kind of stuff. And then at the top, of course, we need to sort of reevaluate and utilize the staffing well. So let's go take a look at each of these layers and each of these elements in a bit more detail right now. Before we do that, though, this is an old chart. I'm sure many of you have seen this before, the different manufacturing or the different reliability philosophies from run to failure, preventive, predictive, although I prefer condition-based than the word predictive. Predictive has some different meanings sometimes. And this thing called precision. And of course, a lot of us today are probably quite proud of the fact, and as we should be, that we're doing, quote, predictive maintenance. When you consider that 80% of your failures are random-natured failures, then it's very, very important that we do some kind of condition-based maintenance, and of course ultrasound is a big part of that. But remember that the predictive side of it really is only identifying the problems. If you don't actually go ahead and take steps to prevent the problems from happening again, reoccurring, then you're going to be doomed pretty much to dealing with the problems later on. So this thing that we call precision maintenance in our world is very important because it is improvement-based. All of the others are failure-based. And again, failure-based is referring to how we identify the work. Predictive maintenance is very good, don't get me wrong. It has a lot of value. There's a lot of value to picking out problems at their early stages as they are failures before they become breakdowns. My question is, how much more value is there to preventing the failures from happening in the first place? So let's look at each one of these items in a little bit more detail, starting with ASD, or Asset Strategy Development. ASD is basically a systematic, a scientific, and experience-based system for developing equipment care strategies. It's based on the thinking and the principles of RCM, but treats it in a slightly less rigorous manner, in other words, to make it more practical and doable. One of the things that we really need to do in the reliability and the maintenance operations world is de-emotionalize the maintenance and operational decision-making processes. Very often we go to a plant and we'll have planning and scheduling in place, and they'll have the plan ready on Thursday for the following week and everything. But what actually goes into that plan and what gets selected to work on is often a result of negotiation and who can bang their fist on the table the loudest. And so it's a very, very emotionally charged situation. We have to de-emotionalize that process. We've got to take emotion out of it and look at it from a systematic and a scientific way. And that's really the purpose of ASD. We can use it to develop a new strategy on a new piece of equipment. We can use the same processes to evaluate existing ones. We use a process called reverse ASD that actually looks at the existing strategies you have and evaluates those against what could happen and what failures may be happening. So it's a systematic way to de-emotionalize the system. It's based on the same questions as RCM plus one, actually. It's 8 questions for us, and RCM, of course, only has 7. What does the asset do? What's its function? How does it fail? How does it not do what it's supposed to do? And then why does it fail? And of course, the heart of this whole process is a failure modes and effects analysis, FMEA. And this is where we drive down to what we call the do-tos. Bearing fails due to lack of lubrication, or due to improper installation, or due to overheating, due to environment, or whatever. The whole idea is to drive down to a point where we can come up with a task that will allow us to mitigate the failure. We also look at consequences. You must ask yourself, what happens when it fails? What are the consequences of the failure? And the biggest question of all, and this is probably the most important thing of all, is the failure age-related or random? As we know, 80% of failures are random-natured, and only 20% are age-related. And that is a very, very difficult paradigm to change. If you go back to your relative plants and mills and wherever your workplace is, and you start asking around about how things fail, the vast majority of the population will be convinced that everything is an age-related failure. We hear it all the time. And it's not. It's completely the opposite. And so, if you guys are all involved in reliability, one of the things, the biggest thing you can do is convince people. It's the hardest thing, but it's very, very important. Convince the people in your organization that random failures exist. Because as soon as we understand random failures exist, we also then understand that no amount of time-based maintenance on an asset is ever going to eliminate the failure modes. So we've discovered age and random. The next thing is, what should we do about it? What is the task? This could be, obviously, for random failure modes, this is some kind of condition inspection task, be that just look, listen, and feel, all the way through an ultrasound, formal ultrasound round on bearings and things like that, or steam traps perhaps, through vibration analysis, infrared, and the rest of the technologies that are out there. How often should we do it? This is another question that people often struggle with. And really, when we talk about how often the task should be done, the mistake a lot of people make is they base the frequency of the task upon the criticality of the machine. I hear this all the time. Oh yeah, we do vibe readings once a month on these machines, but these two over here are really critical, so we do vibe readings once a week. The time or the frequency that you should perform an inspection task is purely a function of what we call P to F, which is the point at which you can detect the failure and the time difference from that point to the time at which the functional failure occurs. In other words, it's how long it takes to fail, to go from a failure to a breakdown. And ideally you take that time and divide it by 2. But that is completely separate from criticality. So the mistake a lot of people make is they end up overlooking at machines. You have 4 different people going and looking at this machine, which is actually not necessary based upon the failure mode. And then the final is who should perform the task, and this is something that RCM doesn't address, but we try to with ASD because we think it's important. And bottom line is, for it to be cost effective, you need to select essentially the least expensive person that can still adequately perform the task. I see a lot of places where they use either outside contractors or PDM technicians, which are probably your most expensive people because you've invested a lot of money in their tools, equipment, instruments, and training. And they're using these folks just to do visual inspection, which to me doesn't really make a lot of financial sense. Better to use somebody who has a less negative effect on the bottom line to do those types of tasks. Of course, in essential work systems, which is the foundation element, this is all about planning and scheduling work effectively. And again, we've got to have a system in place to execute our work in an effective and efficient way. And notice the use of the words there. We have to be effective before we can be efficient. So how does your work management system function? When I go into a lot of different facilities all over the world, there's always a certain amount of dysfunction in the work management system. Some are better than others. A lot of times, though, I'll look at what work the planners really do. And if you look sort of down deep in your heart and you look at what the planners really do, they spend a lot of time expediting parts and basically scheduling and supervising people, which is really not what planners should be doing. Ideally, if you wave a magic wand, an ideal situation, a best practice, in fact, is to have a planner and a scheduler as 2 separate people, because planners need to plan. They deal with what needs to be done and how it needs to be done. Schedulers should be dealing with who needs to do it and when it needs to be done. The problem is if your planner is a scheduler as well, when they develop the plan, in the back of their mind, subconsciously, they'll be thinking about the schedule. And so the plan will never be the correct plan. It'll just be whatever they can do within the schedule. And that compromises the planning side of it. If you can separate those 2 functions, you usually end up much, much better off. So here's a quick example we use in some of our classes. Some of you may have seen this before. What you have there is a little Lego house. It's a 3-story house. How long do you think it would take 3 people to build that house? It's examples, again, that we use in class. And typically, when we hand them a bag of parts and a full parts inventory and a list and say, go build it, and then give them some plans a little later on, it's going to take them about 35 to 45 minutes first time through. Then, of course, in the class, we talk about planning and scheduling, and we have them plan it and schedule it. And if you're thinking about 30 minutes to build that house, you're not quite right. Our record for that particular house is 96 seconds when properly planned. And actually, that was done with a group of 4 people. There were 3 people building, and 1 was just watching and doing QA. So again, that's a real illustration of how effective planning can be. Unplanned work costs 10 times that over planned work. These numbers are fairly well established. And when I look at some of the issues that we face in reliability, not having time to do precision and not having time to do this, a lot of times we can go back to a planning system that could do with a little bit of improvement. Of course, metrics and measures I'm going to talk about in a minute, but these are, of course, a foundational element. It's a basic human need to be able to see improvement and progress. We have a basic human need to be able to do that. If you want a human to change their behavior, if you want me to change my behavior, then the only way I will do it in a sustainable and continuous way is if I can see what's in it for me. That's what WIFM stands for, what's in it for me. So I have to see that the future state is better than current state. And Sometimes the metrics and measures that we put in place really don't do that. You know, how would you measure reliable manufacturing progress? How do we actually measure that? And again, this is more of a strategic question. And a lot of times we have strategic type measurements mixed up with application and tactical measurements. And so we end up with this just big bucket of things to measure, and we end up really just being slaves to the measurements instead of really using the measurements to drive behavioral change. So this is what I'm going to be talking about here in a little bit, this strategic, tactical, and application thinking, and how we tie metrics and measures to reliability improvement, and how we tie them, most importantly, to our business goals. The essentials are, of course, the first layer of bricks in our house, and again, this really deals with the foundational skills and essential skills. We don't use the word basic in our organization because none of this is basic. It's all essential. And these have to be put in place first, and the advantage of doing these this way is by putting these essential skills in place, you see quick return on investment. You get a short-term improvement and easily measurable improvement. So you get to see quick returns. We're talking about craft skills, of course, things like balance, alignment, assembly, these kind of essential skills. On the operations side, of course, inspections and effective rounds. And one of the outcomes of effective rounds and inspections, and again, one of your goals for any of you that are embarking upon or have embarked upon an asset care strategy or basic care programs and things like that, one of the huge things that these types of inspections will bring to the table is a significant improvement in the quality of the work requests that are put in. So it helps significantly your planning and scheduling system. We see a lot of times where operators are encouraged to go out and do inspections. They basically take the numbers, write them down on a piece of paper, and they're not really required to think much beyond that. And eventually, then the work request comes through. The pump broke, pump won't pump, and that's it. Well, unfortunately, when faced with that kind of work request, a planner then has to either dispatch a mechanic to go troubleshoot, or more often than not, they'll go out and troubleshoot themselves, which takes them away from the planning piece. By encouraging our operators and getting them to a position of knowledge where they and building their knowledge and skills where they can be the first line troubleshooters, dramatically improves the quality of the work request. Pump not pumping due to cavitation. All of a sudden, that gives you a much better action item than just pump won't pump. So very, very important from a variety of different levels is engaging our operators. Of course, condition monitoring, and there are a variety of different tools out there. These technologies, of course, are widely applied now, and really should be used in support of your visual inspection. They can give us much, much greater warning of potential problems. The next layer of bricks, of course, is technology, and again, we need to use technology to leverage the skills, not the skills to leverage the technology. I think we're all guilty of throwing technology at people problems once in a while, and if we could just use the technologies to leverage the skills that we already have, in other words, our inspection skills. For example, a strobe light is not a terribly high tech, but it is a piece of technology. We can use a strobe light to leverage our visual inspection skills to allow us to look at a piece of equipment while it's running, to do visual inspection on rotating parts. Sound and vibration, ultrasound, of course, are all quite closely linked. Heat and infrared also, of course, merge together. So again, we must use this technology to enhance the existing skills, but not to replace them. We still need those essential skills in place. One of the mistakes people sometimes make is they do management systems first, and then what happens is everybody tends to be the slave to the management system, which unless you know what you need to manage, it's hard to build a management system, if you see what I mean. So it's always a good idea to try to build the management systems once you've got your feet wet and know what needs managing. Otherwise, you end up just, as I say, being a complete slave to the system. At the higher level, we have things like continuous improvement. You notice that we have RCA, root cause failure analysis, at the highest level. So it comes later in the process, and we have a reason for that. And one of the reasons the main reason we have that is because if you do RCAs at the ground level and you start by doing RCAs, then you don't end up doing anything until you've had a failure and you've done an RCA. So you set yourself up to build a failure-based system. So we prefer to use ASD to drive that, to anticipate the failures instead of waiting till they occur. And then once we've anticipated the failure, put a strategy in place to prevent it. So we just do that slightly differently. So we're about sort of halfway through. Maureen, are there any questions at this point, or shall I just keep going?
We do have just a couple questions, so let me pull that up here. So someone's just wondering, like, what tools you would recommend to help kind of rate where folks are. So, how do we know we're doing well on our planning and scheduling? If that's working, are there any kind of tools that you can suggest that folks could find online, or that you could provide to kind of help them kind of rate themselves?
Sure. And actually the next section here on metrics, towards the end of this section, I'm going to talk about some sample tools, primarily around precision maintenance. But there's a pretty good suite of metrics and measurements that can be used. The SMRP obviously have a bunch out there, and they're organized into different areas, and planning and scheduling is one of them. There's a lot of metrics. I mean, the percentage of planned versus unplanned work on that particular subject, to me, is always an important one. And of course, you're not all going to be 100%. Not all work needs to be 100% planned either. But you need to set these goals. But that's actually the next little subject here. So maybe I'll revisit that afterwards.
Yeah. Okay. And then one more that does kind of relate more to what you've already talked about. You mentioned that it's really tough if an organization has to rely on one person to do both planning and scheduling. So just wondering, if that really is their only option and they can't get around that and have two separate folks, do you have any kind of tips for kind of keeping that person when they're actually doing the planning, keeping that scheduler part of their brain turned off?
Yeah.
Just kind of any advice for folks that might be dealing with that?
Yeah, tinfoil hat usually works. No, no, it's very, very difficult. It takes a pretty unique individual to be able to compartmentalize like that. I actually had one facility a few years ago where it was kind of interesting. They had the same setup. It was a relatively small facility, and they had one person doing both. And the way he managed it was kind of unique. He had a planning office and a scheduling office. And the planning office was located about as far away from the shop and the place where all the maintenance guys hung out as possible. And his scheduling office was, of course, right next to the lunchroom. And so he'd do, when he needed to go do planning, he'd disappear into his office. And of course, this was a few years ago before we all had the cell phones attached to the hip and stuff. But he found he was able to sort of concentrate on planning in his planning office, and he had all the files and the information he needed there. And then when he came to scheduling, he was always right next to the lunchroom, so he could really sort of tell who was where. So that sort of struck me as a kind of unique way to try to handle it. And I understand that in many cases, we don't have a plant big enough to be able to justify those two individuals. So.
Yeah. Well, that's a clever suggestion. So, all right.
Yeah.
Well, that's it for now. I think there's another question in here, but it is a little more related to the metrics. So we'll let you get through that, and we'll ask it to you in a little bit.
All right. Sounds good. So, one of the things we were talking about before, if you really want to improve anything, and this is not just relating to reliability, this would be anything, we have to have measures in place. We have to be able to measure it, otherwise you can't improve it. And a lot of times they're either not put in place, or if they are put in place, the wrong ones are put in place. And so what I want to talk about now is a way of sort of breaking these metrics down into what we call strategic, tactical, and application work. and how they all kind of fit together. Because a lot of times if I'm down on the shop floor and I'm turning a wrench, it's really hard for me to relate the fact that I used a torque wrench and tightened this bolt correctly back up the chain to the the business objectives of the facility. And with that being disconnected, then I really have no value as working on the shop floor for metrics and measures. So what I want to do is talk a little bit about how we sort of tie that together. And of course, it really all starts with what is your strategic intent? What is your business intent? What do you want to be? A lot of companies have a quote-unquote mission statement. Some are okay. A lot are, nice. I mean, they're nice pieces of prose, but they don't really tell you very much. What we talk about is what's your intent? What's the intent statement? And this is just an example right here. This is a pretty high-level strategic intent statement. And again, it's just a sample. It doesn't mean to say this fits your particular facility. But our intent would be to continuously improve the operations and maintenance of our plant assets to become the best XXX company in the world. Employ various methodologies and processes so that productivity and uptime is maximized, total costs are minimized, while producing consistent quality production, therefore increasing profitability. Now, it sounds like a long kind of wordy piece, but if you look at that, it's actually very cleverly written, because it allows anybody to look at that and determine whether they are working on the right things. Because the bottom line is what it states is we're going to try to become the best in the world. Okay, that's nice, that's the vision. But to do that, we're going to use methodologies. We're going to do it systematically. We're going to have methods and processes in place. We're going to increase productivity and uptime. We're going to minimize costs, but produce consistent quality production and therefore increase profitability. So if I come to work in the morning and I'm not working on some kind of methodology or process, increasing productivity or uptime, minimizing total costs, then what am I working on? I'm probably working on the wrong things. So a well-written intent statement should allow anybody to read it and say, am I working on the right thing right now? This is a one that's a little bit more focused on just reliable manufacturing. And really, an intent statement around reliable manufacturing would be to create, implement, and sustain and institutionalize a process, a reliable manufacturing process that positively impacts the business objectives. Reliable manufacturing always needs to be tied back to a business objective. It's not about making machines run smoothly. It's about making more widgets, and that sometimes is difficult, especially for guys like me who are technical in background, to sort of come to terms with them. And I love to make things run smooth, but you'll spend a lot of money making stuff run smooth, and it may not be really the wisest use of the budget. So the whole metric thing starts with a compelling business story, and really that story should be tied to business objectives. These are what we call strategic type goals. So we want to be at X% production by the end of the year, or we want to make so many million widgets by the end of the year. So these are usually high-level plant strategic goals. Okay. Now what you need to do then is say, okay, well, what are the elements that will control those strategic goals? And for us, if we look at this from a reliable manufacturing perspective, we have 4 pillars that we focus on in reliable manufacturing. Number 1 is organizational effectiveness. Number 2 is precision maintenance. We have asset condition assessment and process excellence. So those are the 4 pillars of reliable manufacturing. So on each of those, I can build metrics. I can have my strategic plant metric at the very high level, and then the tactics that we're going to employ to become or succeed with our strategic metrics would become the best at organizational effectiveness, precision maintenance, asset condition assessment, process excellence. So these then become what we call tactical work, and we can put tactical measures around those. But if we look at the strategic level, what would some of the metrics look like for organizational effectiveness? Well, ASD for us is a big part of organizational effectiveness. So I could look at a metric that counts the number of assets that have ASDs completed on them. Well, we have developed a formal strategy for as a metric. A leading indicator there would be the number that we're doing, how many ASDs are being completed or have been initiated. Work system effectiveness, and there's, as I said earlier, there's a bunch of metrics around work system effectiveness, from the percentage of breakdown work to tool time, to wrench time rather. There are another one that I like to look at is when is the schedule complete? Are we scheduling a week out? Are we scheduling a day out? What does that look like? And there are metrics that surround that as well. In the area of asset condition assessment, a high level, some metrics around that, strategic metrics, was how much work is being generated from asset condition assessment activities. How much of your work is generated from some form of condition monitoring? If you think about 80% of our failures being due to random natured failures, then it should follow that 80% of our work, or somewhere in that vicinity anyway, should be generated from condition monitoring. In the area of precision maintenance, the number of machines we have placed in a precise state should be important. And on process excellence, how much work again is being generated from our process rounds, how much true work. And I can put strategic metrics around all of those items. If we just take one of those tactics now and break it down, and we'll take precision maintenance. The tactics that we require to do precision maintenance are as follows. We need foundational skills. We need to be able to assemble and install our machines correctly. We need to have our technicians eliminating problems and understanding how to eliminate problems. And then there are different skill sets around specific assets that we need to address, such as pumps, seals, bearings, and things like that. Each of those, again, when we're looking at reliable manufacturing, I can put tactical measurements in. So my assembly and installation tactic would support precision maintenance, which then goes on to support my big-time business objectives. So once we have decided our tactics, the next step would be to drive down to a lower level again, which is the application level. And again, if we just take the assembly and installation piece tactic and drive that down, we now get down to the sort of nuts and bolts of things. And in the world of doing well at assembly and installation, we have precision measurement, we have fits and tolerances, we have torquing and tensioning, pre-alignment assembly, and all of these sort of pieces of work that need to be done. And I, again, can put metrics around those pieces of work that measure how well I'm doing. And then by tying the fact that I'm now measuring fits and tolerances, and let's say that last week I measured that 75% of my bearing installations, we mic the shafts to 1/10 of a thou as a metric, a scorecard. That then ties me to the assembly and installation, which then ties me back up the pyramid to the business objective. So for each level, we need to know where the business intent is and tie it. So you have strategic global measurements of success. Those are the high-level, plant-level, overall reliability type metrics. Then you have the tactics, which allow us to determine what needs to be done and where. And then the application indicators are down at the application level. And again, as we start to think through this strategic, tactical, and application thinking, remember that one person's strategic work is another person's application or tactical work. For example, at the plant manager level, their strategic work is probably the tactical or application work of the corporate VP. The plant manager's application work becomes the strategic work, perhaps, of the supervisors, and so on and so forth. We need to know where we fit in the organization. So let's just take a look here at sort of general comments around measurements and metrics. And the first thing you have to ask yourself is, what are you trying to do? What do you wish to achieve? What are the behaviors that need to be modified to get there? And this can sometimes be a painful discovery. We first of all need to determine what needs to be improved. Okay. Again, you go out, you start asking questions, you audit, you can benchmark, but this can sometimes be a difficult conversation, you know. And again, the only thing I can counsel you on is take the emotion out of it. Put a process in place that takes the emotion out of it. The next thing we need to do, and part of determining what needs to be improved, is of course closely reviewing what current state is, understanding where we are right now. And again, if emotion is allowed to creep into this, it gets fairly charged. But if you can de-emotionalize this using sort of systematic benchmarking type metrics and measures, then it becomes easier. You also have to sit down and ask yourself how much progress is possible. Yes, I'd like my machines to be 100% reliable 100% of the time, and I'd like to never have another breakdown before the end of the year, but is that really possible from where we are right now? And it's all very well to set stretch goals, but again, a basic human trait is we must have the thought in the back of our minds that we can be successful and we can achieve success. If we lose that thought at any time, then as human beings, our psychology tells us that we give up. So setting too high a goal standard can sometimes have negative effects. We need to develop a plan, and this is something that we rarely do, at least we rarely do well, is come up with a systematic plan to apply or implement the process, and of course that plan, included in that plan are the measurements of success. Another thing we need to do along the way is identify and apply best practices. Many of you listening today are probably from large corporations, or some of you anyway are from large corporations with multiple facilities. One of the things I see in corporate America today is poor communication between the individual plants. We have situations where, you know, plant A has had a particular problem with a machine, plant B has the same machine but doesn't have a problem with it because they solved the problem by doing a certain thing 30 years ago, and there was never any communication between the two. Those of you that do have multiple facilities, it's a tremendous opportunity to leverage knowledge. And again, with technology, communication technology the way it is today, we should really look into doing some more of that. We also, of course, as part of our plan, need to create the methods to sustain and institutionalize what we're doing. So here's an example of applying metrics, and this particularly applies at the precision maintenance level. And basically what these guys did is they sat down and said, maintenance effectiveness. We will become, one of our strategic goals is to become maintenance effective, or improve our maintenance effectiveness. And they sat down with operations and they sat around a table and they said, okay, well, here we go. Basically, maintenance will be viewed as more effective to plant reliability, profitability when unscheduled board mill downtime is at less than 4% of scheduled machine time. And that's a strategic goal. That's a very, very high level goal. It's measurable, of course, but it's at the high level. The current production rate, 72.6%. The 2008 goal is 76%. That's with the outage time backed out of there. So you take 76% of 84.24, and that gives you 6402 hours. Multiplied by 0.4, you end up with basically 5 hours of unscheduled downtime a week. So from my strategic mill downtime less than 4% of scheduled machine time annual goal, I can drive to a 5-hour of unscheduled maintenance downtime per week goal, which is, of course, a more of a tactical goal. All right, so you can tie strategic straight to tactical. So effectively what we're looking to try to do is keep less than 5 hours of downtime a week. That's an easily measurable goal. It's also something that we can manage. We can scorecard that, and if we're more than 5 hours a week, we are in a red light zone. If we're at 5 hours, we're yellow, and if we're better than 5 hours of downtime, we're green. Okay, so right there we have a tactical goal that is assisting or supporting a strategic goal. We like to use the traffic light red, green, yellow to illustrate that. So the next question we have to ask ourselves is, how do we get there? And they sat down again and said, okay, how do I influence board time? They said, well, number one, we need to implement vibration condition monitoring. We need to do 2 precision attempts per month. We want to have X machines per quarter in a precise state, and we want to achieve $50,000 in annualized savings of reduced energy. And they also want to track their top 10 machines. So again, having driven to, I want 5 to improve my board mill downtime, they said, okay, what am I going to do to try to improve that? And these were the things they come up with. So the first thing we're looking at is overall vibration levels. They go out and they trend overall. First of all, you have to have route compliance, so they go in and make sure that they have compliance. In looking at overall vibration levels, plant-wide vibration, it's a strategic metric. It tells you whether you're sustaining, improving, going up or down. The actual numbers don't mean much. We just want to see it's heading down. But it's a very, very slow long-term trend. If you do that by area, the overall vibration trend area, it's more of a tactical measure. So I can really go into an area and start to reduce the vibration levels. The top 40 or the top 10 trend is the one that's going to respond first as we start to improve our machines. And another measurement around, or a metric that can be put around vibration, is the number of machine sets above 0.25 inches per second peak. So here's some examples of some scorecards based upon the percentage of compliance. So they felt that if 95% of their routes were complete, that was improving, 98 to 85 was sustaining, and if you're less than 85%, you were failing, and therefore needed to improve. And again, they report this, or you could report this plant-wide at the strategic level and area-wide at the tactical level. The overall vibration trends are not really an indicator of health. They're just an indicator of, are you improving? Are you getting better? Okay, there's a definite relationship between the way machines run reliably and their vibration level. So these are, again, I'm going to run through these pretty quickly because I know time is getting short. But these are just some of the metrics that they use, the percentage of machine sets above 0.25. And then you can, of course, Pareto this out and do charts. Again, the overall vibration index, we just want to make sure that that's heading down. We don't really care what the numbers are. It just needs to be heading down over time. But this is a long-term goal. Your top 5, your top 40 trend is the one that will respond quickly as you start to improve machines. In terms of, again, we just talked about that. The number of machine sets placed in a precise state, they wanted to, realistically, you're going to have to put about a third of all your machines into precise state before you see a significant improvement in reliability. So their goal was to try to get a third of their machines into a precise state as soon as possible. The first thing you need to do is set up attempts, and typically in the world of precision maintenance, we'll see 2 attempts for 1 success. So your hit rate is typically 50%, certainly at first. So they decided they wanted to see so many machines in a precise state before the end of the year, and from that you can calculate backwards how many attempts you need to make, and then you split it up between the number of craftsmen, and you come up with that's why they came up with 2 attempts per craftsman per month. And again, that's an application metric that can be measured. It's a leading indicator. This bottom one here is an interesting one, and this is something I would really encourage people to look at, is what percentage of the work during outages is being devoted to precision or improvement work. How much is improvement work versus how much is just repairing things that have already broken. And again, there's our scorecards there. Again, the outage improvement work is really a good measure of how much real work is going on, real improvement work is going on. They felt that 15% of the total man hours in outages should be applied. That means you're improving, 10% sustaining, and then less than 5% was failing. Energy consumption, of course, this is a place where ultrasound plays in terms of air leaks, but also precision maintenance. When machines are in a precise state, they consume less power. It should be something you should be tracking. And a lot of times, you know, if we do a class for, say, 15 craftsmen, if they all go and put a single machine into a precise state within 30 to 60 days of finishing the class, then the energy savings accrued from that will typically pay for the class itself. So this is a short-term improvement. It's an application thing that'll give you a short-term gain, but it will get you over that hump on the way to improving reliability. We like to look at dollars per horsepower per year in terms of the to try to equalize the focus on the smaller machines. And when we look at the smaller machines in terms of dollars per horsepower per year, they're way, way more expensive than the big machines. You spend a lot of money on a big machine, but you do it so infrequently that most of your dollars are going to the smaller machines. I've actually seen some of these pitter machines, $2,000, $3,000, $4,000, $5,000 per horsepower per year. My record, I think, was $20,000 per horsepower per year, and that was a half horsepower motor. A lot of these other trends that we see, I just want to get down to a slide back here. A lot of the other trends that we see, such as maintenance costs and numbers of repairs, are very, very good supporting measurements. They're very good supporting measurements, but we prefer to use the other ones, which are much better leading indicators. I think I'm getting towards the end, Maureen. These are just some slides that we use in our overview sessions for managers that sort of talk about the timetable, if you like, or the schedule that we use for implementing this. And again, when we come in and help or work with the management teams prior to doing any precision maintenance classes, we try to lay out a schedule with the metrics and the measures at that time, because it's really important that they create the expectation that precision maintenance is going to happen. A lot of times, we'll come and train the guys and they'll be all ready to go, and the craftsmen will be ready to fire it up and ready to do work. But then again, it sometimes doesn't take, because the supervision didn't create that expectation. So I think that's about it. Again, from my perspective, go back to the pyramid here, and the different parts of process excellence, the different parts of reliable manufacturing. I think, Maureen, that's probably about all I've got. I notice I'm kind of running over, but what else is new, right?
That's okay, no problem. No, that was really great, and while this whole process, obviously there's so much to it and so many questions to ask and so many questions to answer, and yet it always seems to go back to, if you don't have the people on board and everybody on the same team on this, it's funny how that human element could just wipe away all the hours in the room doing all this work. So it seems to be kind of that most critical piece. And I like how you mentioned taking the human element out as best you can, and not taking feelings out of the equation and everything. So I'm sure you're just saying that all the time.
Yeah, I mean, emotion is a wonderful thing in a lot of respects, but a lot of times our emotions kind of run away from us a little bit when we're making maintenance decisions, and invariably that sort of leads to problems later on.
Yeah, so all right. Well, that was great, and I think you must have just answered everybody's questions, or they're all still digesting it. But
Yeah,
I encourage folks, as you're kind of stepping back from this and thinking, oh wait, I would wish I could ask that, or would love to talk to Tim about this or that. You can see his contact information up here, but you can also send questions through us, and we'll be happy to connect you with Tim so you can have a conversation and get some things answered offline. So from there, I'm just going to pop the screen back to me. I've just got a few closing slides here.
You bet.
Again, I guess we'll kind of skip over the questions, but again, I do encourage folks to keep thinking about those and sending them in after the fact. So just want to make you aware, as always, our website, uesystems.com, we've got all kinds of information, as well as all of our previously recorded webinars, just like today's. So we hope you use that as a resource, and of course use Tim's organization and his company as a resource as well. if I can get my mouse to work here. There we go. And we also, hope you'll stay connected with us in between these webinars. We've got a couple of groups on LinkedIn, so you can find us there. We hope you'll join in. That's always a good place to pose questions, get some advice from your peers. We're on there answering questions. Folks like Tim are on there as well, helping out. So just a good place to get some advice and to also provide it. And we're also on Twitter. We've got our Sound Advice blog, so just trying all the different vehicles to stay connected with you all. And some important dates and kind of an exciting announcement as well. Our next webinar will be September 18th, and we're going to be talking about planning and scheduling.
Perfect.
So there you go. This was a good intro to that. So look for an invitation to that here soon. And then our Ultrasound World is going to be next May. You see the dates there, and that will be the 10th anniversary. And what we're excited to announce, we're going to co-locate with our Ultrasound World a brand new conference that's going to be called Reliable Asset World. And I'll just pop the website up here so you all can see. It's just reliableassetworld.com. And we're really excited to offer this as a new conference. Tim is actually going to be coming and speaking, so we're excited to have folks like him supporting this. And we're just going to really focus in on all things reliability and everything we can do to bring good speakers to give content on asset health, topics like planning and scheduling, change management, so touching on that human side of things as well. So we're really excited about this. So go ahead, take a look at the website, see if this is something you can get on your schedule and on your approval check sheet, and hopefully you all can join us and make this a really great first event. You'll be hearing lots more about this and our Ultrasound World Conference as we move along here into the fall. And Tim, again, thank you so much for being with us today, and we'll look forward to seeing you in Clearwater, Florida next May, if not before then.
You bet. Thanks, Maureen.
Great. Well, everybody, go have a great rest of the day. Enjoy the rest of your summer, and we'll see you back here in September and kind of just keep on moving. So everybody have a great day. Thanks.
Thanks, Maureen.